Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and LOL Mathematics Paper 5, which is a Probability and Statistics 1 for February-March 2022, and the code is 9709/52. Let's move on to question number 1. So for question number 1, a fair red spinner has edges numbered 1, 2, 2, 3, and a fair blue spinner has edges numbered -3, -2, -1, -1. Each spinner is spun once, and the number of the edge on which each spinner lands is noted. The random variable x denotes the sum of the resulting two numbers. A. Draw up the probability distribution table for x. So from here, I will write R is 1, 2, 2, 3. Then the blue one is -3, -2, -1, -1. So now I will just draw a table. So let's say this is for to represent the red spinner. Okay, so it will be 1, 2, 2, and 3. These are the edges. And then for the blue spinner, this is the blue spinner showing -3, -2, -1, and -1. Okay, so now since we are interested to get the x is the sum, right? So the table will show you the sum. So now from this table, -3 plus 1 is going to be -2. -3 plus 2 is -1. Here same. -3 plus 3 is 0. Then -2 plus 1 is -1. -2 plus 2 is 0, 0. So -2 plus 3 is 1. -1 plus 1, 0. Okay, here also 0. So -1 plus 2 is 1. This is 1. -1 plus 2 is 1 for both. -1 plus 3 is going to be 2. So the red color means the sum. Alright. So from here, I will get my probability distribution table of x. So obviously from the table, it shows that my x will be taking few values. The first value is -2, the smallest value, then followed by -1, 0, 1, and the largest is going to be 2. Okay, so when it is -2, I see 1 time. So 1 out of, now in this table, there will be total of 16 values, right? Total, I mean, there will be 16 sum. Therefore, 1 over 16. And I see 2 times of -1. So the probability will be 2 over 16. 3 times, no, sorry, 1, 2, 3, 4, 5. 5 times of 0, so 5 over 16. Then when x is 1, I will have 5 times, so 5 over 16. And same goes to the 2. I have 2 times, so it will be 2 of 16. So this will be, okay, let me check. There will be 3 times of -1. So the probability for -1 should be 3 over 16. Now you can double check, make sure the total of all these probabilities equals to 1. Okay, so that's the solution for the first part. Now for second part, given that EX is 0.25, EX is 0.25, which is the expected value, find the variance X. So now our variance X is counted by EX squared minus square of the expected value. So now I have to count the EX squared. So EX squared is counted using this formula, which means you sum the product X squared multiplied with the P. So now I square the X and multiply with the P. After that, plus with another pair of the answer. So I will get -2 squared times, the probability is 1 over 16. Then my next x is -1. Then you square it. The probability is 3 over 16. Then next x is 0. So no need to times the probability because it's 0. Then after that, 1 squared times 5 over 16. Followed by 2 squared times 2 over 16. Okay, so from here, when you calculate all, it will be 20 over 16, right, which is 5 over 4. Now, my variance, x, is going to be ex squared minus square of ex, which is 5 over 4 minus 0.25 squared. Then you will be getting 19 over 16. So that is the variance x. Now, question 2. In a certain country, the probability of more than 10 centimeters of rain on a particular day is 0.18. And it is independently on the weather of any other day. A. Find the probability that in any randomly chosen 7-day period, more than 2 days have more than 10 centimeters of rain. Okay, so now obviously this is binomial because binomial distribution because you are considering 7 days, and the probability of having more than 10 centimeters of rain is 0.18, right? And they are independent. So I will write x is binomial distributed with n is 7 because we consider 7 days, and the probability of raining of more than 10 centimeters is 0.18. So this x is how many days with more than 10 centimeters of rain. So now it's given that you need to count probability that more than 10 days. So px more than 2 days, okay? More than 2 days. So px more than 2. So when px more than 2, it will be 3, 4, 5, 6, 7. So I will just use 1 minus all previous. So 1 minus px equals to 0, 1, and 2. Okay, so for your information, the binomial distribution, x is binomial and p, the probability is going to be ncx, px, qn minus x. Then from here, I will be getting 1 minus. Now, from here, from this distribution, the p is 0.18, the q is 1 minus 0.18, which is 0.82. So now, if px equals to 0 means that no success, means all failures. 0.82 to the power of 7. All 7 days will be less than 10 centimeter of rain. Then, px equals to 1 means that 7c1. Just apply this formula. So 7c1, 0.18, degree 1, 0.82, degree 6, followed by 7c2, 0.18, degree 2, 0.82, degree 5. Then from here, you will get 1 minus 0.884585. So I give more decimal places and final answer round up to 3 significant figures. So this is my solution for first part. Now B, for 3 randomly chosen 7 days. Okay, now out of the 7 days, you consider 3. Find the probability that exactly 2 of this period have at least 1 day with more than 10 centimeter of rain. So at least 1 day out of the 3 days. Okay, and these 3 days is chosen from the 7 days period with more than 10 centimeter rain, which means now I need to get at least 1 day. Okay, so when you refer to at least 1 day with more than 10 centimeter rain, so now your x is 7 days, 0.18. Okay, out of 7 days, right, you have 1 day. I need to find what is the probability first. So px at least 1 day, right? Therefore, it will be 1 until 7. So I use 1 minus px equals to 0. Then this is going to be 1 minus p, since px equals to 0. Now remember, just now I said q is 0.82, so it will be all failures. Right? Then you will be getting 0.7507. Now, from here, I will say that for more than, at least 1 day with more than 10 centimeter rain, that will be with this probability. Alright? Now, from 3 days, exactly 2 days have at least 1 day. Means that now my y is binomial with 3 days, the n is 3, and then the probability will be 0.7507, because this 0.7507 is at least 1 day with more than 10 centimeter of rain, right? Now, out of 3 days, exactly 2 days. Therefore, Py equals to 2. So from here, my P is 0.7507, then my Q is 1 minus P. Therefore, you will be getting 0.2493. Okay, so that is the meaning of this question. So then, when Py equals to 2, it will be 3 C2, 2 successes, and 1 failure. Then at last, you will be getting 0.421 for the answer correct to 3 significant figures. Alright, so now for question 3. At a summer camp, an arithmetic test is taken by 250 children. The times taken to the nearest minutes to complete the test were recorded. The results are summarized in the table. So draw a histogram to represent this information. So for information for histogram, we need to check whether we use frequency or frequency density for the vertical axis, and it depends on the width of the classes. So obviously this is 30, but this is no longer 30, the width. Therefore now I have to draw, I need to count few values, okay? I need to count few values. So it will be, this is the C, class width, right? Or probably I do right here. I will just write here. This is a class width. So how to get class width? Average of these two values, 30.5 minus average of previous value. So previous value will be 0 because there is a gap of 1. So I will get 0.5, and then here is 30.5. Probably before that I just write down the class boundaries. It will be better, because later on when we draw the histogram, the horizontal axis is going to be the class boundaries. So here I will write 0.5 to 30.5. Then this is 30.5, and the average here is 45.5. Then 45.5 to the average of these two numbers, 65.5. After that, 65.5 to average of these two numbers, 75.5. After that, I will expect the next one is 101. So 75.5 to 100.5. That will be my class boundaries. And then now I need to get the C, class width. Now class width just minus the class boundaries. Okay, so obviously you get 30, and then 15, 20, 10, and 25. So now since you get different class width, then I have to get the frequency density. Frequency density is frequency over class width. This is our frequency. So now 21 divided by 30, you will get 0.7. Then 30 over 15 is 2. 68 divided by 20, you get 3.4. 86 divided by 10, it will be 8.6. 45 divided by 25, it will be 1.8. Okay, so now I have to sketch the histogram whereby my vertical axis is frequency density and my horizontal axis is class boundaries, and to represent the time. Okay, so by looking at this, look at the graph here first. So for horizontal axis, let's say I just draw it here. This is my time taken, T minutes. Okay, then the vertical axis is going to be the frequency density. So just draw using a straight line, I mean the ruler. Okay, now look at the range first. The maximum for the frequency density, this is going to be frequency density. So for frequency density, maximum is 8.6, minimum is 0.7. So here we have 1, 1, 2, 3, 4. Okay, most likely I have to use 2, right? So here is going to be 2, 4, this is 0, 2, 4, 6, 8. Okay, then now I better write 10, better label up to 10. Here is 10. So this is my frequency density. Okay, then now my class boundaries, minimum is 0.5, maximum is 10.5. So which means here is going to be 1, 2, 3, 4, 5. Okay, I let this be, here is 0.5. Okay, then here is 20.5, 40.5, 60.5, 80.5, 100.5. Okay, now when it is 0.5 to 30.5, the frequency density is 0.7. So 0.5 to 30.5. Here is going to be 30.5. It will be 0.7. This is 1. Okay, which means here you have 5 squares to represent 1 unit. So means that each square is 0.2. So 0.2, 0.4, 0.6, 0.7, which is here in the middle. Okay, so it will be in the middle. Alright. And then my second graph is, a second bar is 30.5 to 45.5, and the height is 2, 45.5. Okay, here is 50. Here is 50.5. Therefore, 45.5 will be in the middle. That means it's here. And the height is 2. Right. Now the next one is 45.5 to 65.5. So here is 70.5. So 65.5 is in the middle. And then the height is 3.4. So here is 3.4 is here. Right, so please draw a straight line because I can't, I don't have the ruler here. Okay. Now 65.5 to 75.5, the height is 8.6. So 8.6, here is 8.6. Now I have to draw. Here is 8, so 8.6 is somewhere here. Make sure this is a straight line. I'm not drawing a straight line here because it's quite tough for me to draw. Okay, then it will be up to 75.5. So 70 is here. 75.5 is 70.5 is here. So 75 is in the middle. Right. Okay. So then lastly 75.5 to 100.5, the height is 1.8. So 1.8, which means it's here. Okay, so that is our histogram. Right, now B, state which class interval contains the median. Okay, so now look at the total here. The total is 250, right? So the median is the data with this position. So 250 divided by 2, it will be 125. So now you need to find out which class will have this data. So therefore, I have to get my frequency density, I have to get my cumulative frequency, which is a capital F. So the total is 21 up to the first class. So 21 plus 30, it will be 51. 51 plus 68, it will be 119. 119 plus 86, it will be 205. Then definitely this is 250. So from here, my median is the data number 125, which means, right, it will be in this class because the previous class is up to data number 119. So data 120 to 205 will be in this class. So therefore, my median class is 66 to 75. Okay, so my final answer here, median class or class contain median contains the median is 66 to 75. Okay, now see, given an estimate of mean time is 61.05 minutes, state what feature of the distribution accounts for median and the mean being different. Okay, so when you look at here, since the median will be in this class 66 to 75, and then the mean is only 61.05, means that your median will not be equal to the mean, okay, because the median and mean will be in different class already. So therefore, the distribution will be skewed. Okay, the distribution is skewed. Or you can just say it is not symmetrical. Why? Because the mean is not same as median. Right? So that's the solution of this question. Now, question number 4. The weights of male leopards in a particular region are normally distributed with mean 55 kg and standard deviation 6 kg. A. Find the probability that a randomly chosen male leopard from this region weighs between 46 and 62 kilograms. So now for the male, I will write M, normally distributed 55, standard deviation 6, so variance is 6 squared. So now you need to count probability that the male weighs between 46 and 62 kilograms. So from here, we need to standardize. Now, for your information, if your X is normally distributed with mean, mu, variance, sigma squared, when you standardize, it will be X minus mu over sigma. Okay, then from here, I will get P 46 minus mean 55 over 6 is the standard deviation, less than Z less than 62 minus 55 over 6. Therefore, from here, I will get negative 1.5 less than Z less than 1.167. And now, once you get this step, the next step is going to sketch a graph. Then I will mark negative 1.5, 0, and 1.167. And the region is in between. So obviously from here, to get the probability, make sure the region is always towards the left hand side. So obviously it's probability of the positive value, Z less than positive value, minus Z less than negative value. So here I will write P Z less than 1.167 minus PZ less than negative 1.5. But less than negative value is not allowed. Therefore, I need to sketch another graph to represent the negative. So less than negative value is basically the region towards the left hand side, but then I have to flip it to the right side so that the line is the critical value is 1.5, which is positive value. And to get the orange region is basically same as the blue region. So to get the orange region, it is total probabilities 1 minus PZ less than 1.5. So here I will get PZ less than 1.167 minus 1 minus PZ less than 1.5. Okay, and then so the probability for the first probability you can get from the table, which is 0.8784, then minus 1 minus the PZ less than 1.5 is basically 0.9332. Okay, and now when you calculate all these values, you will be getting 0.8116, and now I round up to 3 significant figures to get 0.812. So that's the solution of this part A. Now, the weights of female leopards in this region are normally distributed with mean 72 kilograms and standard deviation sigma kilogram. It is known that 25% of female leopards in the region weighs less than 36 kilogram. B, find the value of sigma. So now I let F to represent the female leopards. It will be normally distributed with mean 42 and standard deviation sigma. So variance is sigma squared. And it's given that the female leopard weight less than 36 kg. So means that F less than 36, and then the probability is 25%. So 25% when you convert to decimal, it will be 0.25. Okay, and now since your F is normally distributed, then we are going to standardize it. So P Z less than 36 minus 42 over sigma. It will be 0.25. Now here, 36 minus 42 is basically minus 6. So from here, we know that sigma is positive. So 6 over positive value, it will be positive, but there is a negative value. So obviously, negative 6 over sigma is on the left-hand side. Okay, and this region is 0.25. Now, since it is negative value, I have to flip it to the right side to get positive value. And then the region will be the same. This is 0.25. So when here is 0.25, the green color, which means all the regions towards the left hand side is going to be 1 minus 0.25, which is 0.75. Okay, so now from the graph, I know that PZ less than 6 over sigma is going to be 0.75, and now my 6 over sigma is on the right side, then I can just use the table. So from table, PZ less than 0.674 is 0.7499. So we are going to take this value because 0.7499 when you round up, it will be 0.75. Then I will write 6 over sigma is 0.674 because when you compare, right, obviously they are the same. Hence, from here, you will get your sigma. Your sigma is 6 over 0.674, and at last, you will be getting 8.90. So that's the standard deviation for the female leopard weights. Now, the distributions of the weights of female and male leopards are independent of each other. A male leopard and a female leopard are each chosen as random. C, find the probability that both the weights of these leopards are less than 46 kg. So now I need to count the male leopards less than 46 kg. Okay, so when you count this and also the female leopard less than 46 kg, now you check. Just now we have counted less than 46 kg, which is here. Right? So I will get this value. So it means that it's less than negative 1.5. So I will just direct refer to first part. So I will write here from A. This is P, Z less than negative 1.5. Okay, when less than negative 1.5, I will just draw the graph. This is less than negative 1.5. This region is going to be same as more than 1.5, right? So that means this is same as PZ more than 1.5. So the 1.5 is basically 1 minus this. So 1 minus PZ less than 1.5. And this probability of z less than 1.5 already found in the previous part, which is here, 1.5. Okay, so I will just take this value, 1 minus 0.9332. Because just now I didn't count the value, otherwise I will just copy from there. So 1 minus 0.9332, and this is going to be 0.0668. This is for male leopard less than 46 kg. And now both the leopards, so we have to consider when female leopard less than 46 kg. So it will be z less than, okay, now 46, because if we didn't count just now, go back to previous part. The mean is 42, standard deviation is 8.9. So I have to minus 42 over 8.90. Then this is going to be p z less than 0.449. When you refer to the graph, okay, when you refer to the graph, 449 less than 0.449 means this region, which is exactly same as the table. So now you can just read this probability from the table, and you'll be getting 0.6732. But then the question is not asking for individually like that, right? The question is asking for both, right? Means that now, since they're independent, therefore you just times both probabilities. So now our probabilities, or our probability, equals to 0.0668 multiplied with 0.6732 to make sure that the female and male leopard also less than 46 kg. Then here is going to be 0.0450, which is 3 significant figures. Okay, so that's all for this question. Now question number 5. A group of 12 people consists of 3 boys, 4 girls, and 5 adults. So 12 consists of 3 boys, 4 girls, and 5 adults. Now, how many ways can a team of 5 people, so from here you choose 5, can be chosen if exactly 1 adult is chosen? So 5, I choose 1 adult. So when exactly 1 adult means that, okay, here I need to choose 1. Alright, then for the rest I have to choose 4. So here I have to choose 4. So from here I know that total is 7. Alright, so obviously this number of ways, because it's mentioned chosen, so it's actually the number of selection. It will be 5 choose 1, 5 adults you choose 1, and 7 others you choose 4. Okay, so from here you will be getting 175. So we have 175 ways to choose the 5 person. Okay, now B. In how many ways can a team of 5 people be chosen from the group if the team must include, if the team includes at least 2 boys and at least 1 girl? Okay, so now I have 12 person, 3 boys, 4 girls, and 5 adults. Now I need to get at least 1 girl. So I will write in this form. This is boys, this is girl, this is adults. Okay, I have 3, I have 4, I have 5. Now at least 2 boys. Alright, at least 2 boys. I need to choose. At least 2 boys, at least 1 girl to get 5%. So here definitely I have to choose 2 boys and then 1 girl. 2 plus 1 is 3, so I can choose 2 adults. Alright, or I can choose 2 boys, 2 girls. So here 1, or I can choose 2 boys, 3 girls, then here's 0. Now for the two boys, done. So now remember we need to get at least 1 girl. So 1 girl, now I consider 3 boys. So 3 plus 1, then plus another 1 to get 5 person, and then I can have 2 girls and 3 boys. then here's 0. So now I cannot choose 4 boys because we only have 3 boys in total. So these are the possible selections, right? All these are the possible selections, means all, right? So from here, to choose the first one, I will say 3, I choose 2. Okay, so look at here now. From 3, I choose 2. From 4, I choose 1. From 5, I choose 2. So all this will be the selection, the combination. So I will write number of selections. So the first one is going to be 3, choose 2, and 4, choose 1, and 5, choose 2. That is for the first combination. Now, for the second combination, maybe I just use different color. Second combination, I will have 3, choose 2, and 4, choose 2, and 5, choose 1. Okay, this is going to be plus because all. Now, for the third one, which is here, it's going to be 3, choose 2, and 4, choose 3. That's it. Okay, or we have chosen 5. Now, the next one is going to be 3, choose 3. Then 4 girls choose 1, 5 adults choose 1. Lastly, okay, it will be 3, choose 3, and 4, choose 2. Okay, so we have to consider all these 5 cases. So at last, you will be getting the total of, so the first one will be 120, second is 90, third is 12, fourth is 20, last one is 6. So at last you'll be getting 248. So this is how I solve this question. Better to draw the table, then you can see clearly, right? And you will not miss out any of the possible selections. Okay, now the same group of 12 people stand in a line. See how many different arrangements are there if the 3 boys stand together and an adult is at the end of the line, which means now you have adult 1, then adult 5. Remember, 12 person, 3 boys, 4 girls, and 5 adults. So now, from here, when 12 person, you already fixed 2 person here, 2 adults there. So 12 minus 2 left 10. From the 10, alright, you have 3 boys. Right, 3 boys must stand together, which means these 3 boys in a group, then I have another 7 left. So now, when we choose this, okay, make sure first step is choose the 2 person. So when you choose a 2 person, we have 2 ways. You can consider A1 first, the first adult, which is 5, you choose 1, and then the last one is left 4. Okay, after you have chosen 1 adult and put it in the first place, then the last one, you have 4, C1. Okay, then here I will say that the middle one, I have 7 person together with one group of B. So that means total will be 8 because here 1 plus 7, it will be 8, right? So here 1, here 7, that means it's total 8. So I will write 8 factorial to arrange this 8 person, and then don't forget we have this 3B. Right, this 3B can be arranged among themselves. So the 3 factorial is to arrange the 3B. So when you calculate this, you will be getting 4838 400. So this will be the number of arrangements. Alright, so if you don't want to use this method, we have another option, which is, now for the A1 and A5, I can just say, out of the 5, I choose 2 and arrange. Therefore, you can write 5P2. So this 5P2 is to, if to simplify the 5C1 times 4C1, I can direct change to 5P2. Then the rest just remain times 8 factorial times 3 factorial. Then it will be 4838 400 as well. Okay, so we have 2 methods to solve this question. Now, question 6. A factory produces chocolates in 3 flavors, lemon, orange, and strawberry, in the ratio of 3 to 5 to 7. So lemon to orange, let the E be orange, strawberry, then equals to 3 to 5 to 7. Now, Neil checks the chocolates on the production line by choosing chocolates randomly one at a time. A. Find the probability that the first chocolate with lemon flavor that Neil chooses is the 7th chocolate that she checks. So obviously this is the geometric distribution. So now our concern is the lemon flavor chocolate. So the lemon flavor chocolate is PL equals to 3 out of, now 3 plus 7 is 10, plus 5 is 15. So I know that the probability of getting the PL is 1 over 5. Alright, so which means not lemon chocolate, it will not lemon flavor, it will be 1 minus 1 over 5, which is 4 over 5 here. Now it's mentioned that the Neil has checked 7 chocolate, 1, 2, 3, 4, 5, 6, 7. This is the 7 chocolate and this is the first lemon flavor. So all the previous one, 6 non-lemon flavor. Okay, so now I will write my probability is basically, this is geometric distribution. So first 6 will not be will be non-lemon flavor, which is probability of 4 over 5, and there will be 6 of them. Then the last one is lemon flavor. Therefore, my probability is going to be 0.0524. Right? So this is geometric distribution. Now, part B. Find the probability that the first chocolate with lemon flavor that Neil chooses is after she has checked at least 6 chocolates. Okay, so here 1, 2, 3, 4, 5, 6. After she has checked at least 6 chocolate flavors, then she only gets the lemon flavor chocolate, right? So that means first 6 are not lemon chocolate flavor, right? So the probability it will be, because it's mentioned at least 6, so I'm sure that to check at least 6 chocolate, after she has checked at least 6 chocolate, then only she found the lemon flavor chocolate, means that first 6 must not lemon chocolate. I'm confirmed. Okay, first 6 not lemon chocolate. So the probability of not lemon flavor chocolate is 4 over 5, and there will be power 6. Then you can just leave your answer in fraction, or you can round up to give your answer correct to 3 significant figures. So this will be the working. Now, surprise boxes of chocolates. Each contain 15 chocolates, 3 lemon, 5 orange, and 7 strawberries. So here I have 3 lemon, 5 orange, 7 strawberries. Now, Petra has a box of surprise chocolates. She chooses 3 chocolates at random from the box. She eats each chocolate before choosing the next one. That means now you are choosing one by one. Okay. C. Find the probability that none of Petra's 3 chocolates has orange flavor. So it will be 3 non-E. So then from here I will just say total chocolates is 15. So the first non-E is, okay, now look at here. Basically first non-E, the non-E is 10, right? It will be lemon or strawberry. So from here I will say the first one will be 10 over 15 non-E chocolate. But after you have chosen one, total left 14. The non-E chocolate left 9, right? Non-orange flavor chocolate left 9, and then the next one is going to be 13, and then the non-orange flavor chocolate is going to be 8. So then here is 24 over 79. You may use this concept to solve this problem, or probably, I would say that this is same as, instead of taking one by one, it is same as you just take 3 at the same time. Okay, then make sure these 3, because we know that they are non-repeating, right? No repetition. Here you take one, after that it, and then take the other one. So instead of taking one by one, I would say I just take all 3 together. So these 3 will be from the non-orange flavor. That means total is 10. So I will say 10 choose 3 over total is 15. I choose 3. Okay, it is the same concept. So at last, you will be getting 24 over 91 as well. Right, so that's all for this question. Part D. Find the probability that each of Petra's 3 chocolates has different flavor. Okay, so now from here, we need to solve 3 different flavors, means that you might get L, you might get E, you might get S, right, in any order. So from here, I will say that L is 3. So this can be 3 choose 1 followed by, or probably I would just say, okay, at first 3 out of 15, then left 14, then left 13. Alright, so the E will be 5, the S will be 7. So here 5, here 7. Now if you use this method, then you have to times 3 factorial, because it can be in any order. It can be LES, ELS, SLE, and so on. So the 3 factorial is to consider the arrangements, right? Then from here, when you simplify, you will be getting this answer. It will be 3 over 13. Okay? So now, you may use this method, or you can just use 3 different flavors, right? It will be 3C1 times 5C1 times 7C1 over 15C3. Okay, so here you will get 3 over 13 as well. So you have 2 methods to solve this question. Okay, now E. Find the probability that at least 2 of Petra's 3 chocolates have strawberry flavor, given that none of them has orange flavor. So P, at least 2 strawberry chocolate. Sorry, 2 strawberry flavor, at least 2 strawberry flavor, given that none of them has orange flavor. So all 3 non-orange flavor. So now I will say this is P, at least 2S, and 3 non-E. 3 non-E over P 3 non-E. Okay, so now go back to just now. We have 12, then 3L 5E 7S, right? 3L 5E 7S. So now if at least 2S, at least 2 strawberries and 3 non-E, which means here it will be 2 strawberries, and now we cannot consider the E. Therefore, strawberry and L, 1L, okay, that is the intersection, or is plus 3S, okay, because Petra's is taking 3 chocolates, then over 3 non-E. 3 non-E means that we will just take from L or S, alright? 3 non-E. Alright, so now from here, to get the first one, I will say 7, I choose 2. So 7, I choose 2. And 1L. So 3, I choose 1. Plus 7S, I choose 3. Over 3 non-E. Non-E means I have to choose from L and S. Means that there are total of 10 here. So 10, choose 3. Okay, so give me time to calculate this. This is 63 plus 7C3, 35 over 10C3, 120. So here you will get 63 plus 35 is going to be 98. So 98 over 120. It will be 49 over 60. Okay, I'm using the combination method to solve this question. So that's the solution of this question. Alright. So this is also the end of the question of this paper. Right. We have come to the end of the video. Thanks for watching. If you enjoy watching my video, please subscribe to my channel and stay tuned for more upcoming videos. Thank you. Bye.